Hello, and welcome to our lesson on simplifying rational expressions. So, we already looked at a few different ideas related to ratios, percents, and things of those sort that involve rationals. A ratio becomes a rational expression, simply put, when a fraction has a numerator and a denominator, which are both non-zero polynomials. So by that it means where the numerator or denominator are neither zero, and a polynomial being anything that's a monomial or greater. So we're going to look at those rational expressions in a little bit. But the first idea we're looking at is the idea that a rational expression is undefined for the values of x or whatever variable it is that make the denominator equal to zero. So if our denominator equals zero, that means our rational expression is undefined. So the way that we do that, and we'll look at a few examples here in just a second, but the idea is we'll set the denominator equal to zero. And then after we look at the idea of undefined denominators, then we will move into how to simplify rational expressions. But the process there that we'll be looking at to simplify is factoring the numerator and denominator, and then dividing out any common factors. So example one here, the first piece that we're looking at, is just the idea for what values of the variable is the rational expression undefined. So that means when the denominator equals zero. So if we're looking at this first example here of 2 over 14x, to find out when it's undefined, we set the denominator, the bottom, equal to zero. So 14x equals zero, and solve for x, which means it's undefined when x is zero. In B, for what value of the variable is the rational expression undefined? So 8 over x plus 4, we take our denominator of x plus 4, set it equal to 0, and solve for x. So x equals negative 4. Same thing with C. We'll take our denominator of 5x plus 10, set that equal to 0, and solve for x. So x equals negative 2. So each time, to find out when the rational expression would be undefined, we're setting the denominator equal to 0 and solving for the variable. So then we look at D, E, and F. In D, we have two binomials in the denominator, x minus 6 and x plus 9. So we set both of those equal to 0 and solve. So x could be 6 or x could be negative 9. Either of those answers would make our rational expression undefined. In E, our denominator is a trinomial, so the first thing we have to do is factor that. So I factor the x squared plus 5x minus 6 into x plus 6, x minus 1. Then each of those set equal to 0, so x could be a negative 6, or x could be a positive 1. And then in F, we have x squared minus 49. So on bottom, we need to factor that, and that factors to x plus 7, x minus 7. So then we set each of those equal to 0. X plus 7 equals 0, x minus 7 equals 0. Solve for x, and x could be negative 7 or a positive 7. So these first 6 examples are just looking at the idea of When is the rational expression undefined, meaning the denominator equals 0? Now we're going to move into the idea of simplifying our rational expressions. So again, to simplify, we'll be factoring the numerator and denominator and then dividing out common factors. So ideally, we're going to be looking for greatest common factors, which we recently have practiced. So moving down to example 2, simplify the expression. We'll just start with A here, 7x over 21. So what we're looking for is, can top or bottom originally be factored any further? No, they can't. So then what do top and bottom have in common that we can divide out? We can divide out the factor of 7 for both. Can't do anything with the x because the bottom does not have an x. So divide top and bottom both by 7. And our simplified expression is x over 3. And B, 28x squared over 35x to the third. So in this case, both of them share at least x squared. So I know I can divide out an x squared. Then 28 and 35 both can be divided by 7. So our greatest common factor, 7x squared, we're dividing top and bottom both by that, and we get 4 over 5x. In C, can't simplify, or can't factor, I should say, top or bottom any further. So now we're just stuck with the idea of dividing out the greatest common factor. 18 and 60 both can be divided by 6. A to the third B and AB can both be divided by AB. So we'll divide top and bottom by 6AB, and we have 3A squared over 10. So can't do any factoring on these first 3 examples. So we're just dividing out the greatest common factor to get our simplified expression or ratio. Then we move down into the next 3 examples. These ones, we can look to do some factoring before we simplify. So our top is 2x, the bottom is 2x plus 10. So on bottom, I can divide out the 2. 2x plus 10, both divide by 2. That gives me 2 times x plus 5. Now, 2x over 2 times x plus 5. The 2's cancel out, so I'm left with x over x plus 5. In E, I have x to the third plus 6x over x squared. So on top, I can factor out an x. So that gives me x times x squared plus 6. Then the x here and the x squared both can be divided by x. So that leaves me with x squared plus 6 on top over x on bottom. And then in F, on bottom, 12x squared minus 3x, I can factor out a 3x. So if I factor out the 3x, that leaves me with 3x multiplied by 4x minus 1. On top, I still have 6x to the third. So then, top and bottom can both be divided by the 3x. The 3x here cancels, so I'm left with 4x minus 1 on bottom, and 6x to the third divided by 3x to the first gives me 2x squared. And then in example 3, now we're looking at the more complex expressions where we need to factor first and then divide out common factors. So we're looking for parts that are shared on top and bottom. So first, if we look at A, trinomial on top, regular binomial on bottom. So our trinomial on top can be factored. X squared minus 8x plus 15 factors to x minus 5 times x minus 3. So then on top and bottom, the x minus 5's cancel. So that simplified answer then is just x minus 3 or x minus 3 over 1. In B, trinomials on top and bottom, so both have to be factored. The top, x squared plus x minus 20, factors to x plus 5, x minus 4. And then our bottom, x squared plus 2x minus 15, factors to x plus 5, x minus 3. So then the x plus 5's can cancel, and our simplified answer is x minus 4 over x minus 3. In C, the top can't do anything with, so that's just x plus 6. Factor the bottom, and we have 2x minus 1 multiplied by x plus 6. Cancel out the x plus 6, so we're left with 1 on top over 2x minus 1. Then with D, E, and F, it's the same idea. So in D, E, and F, we have to factor first, then divide out or cancel out our common factors. So in D, we have 9 minus x squared. So it is a difference of 2 squares just written backward. So when I factor that, I get 3 plus x times 3 minus x. On bottom, factoring the x squared minus 4x plus 3, I get x minus 3 times x minus 1. Now, when you look at top and bottom, 3 plus x and 3 minus x doesn't match up currently with the x minus 3. But because these are in reverse order, what I can do is multiply by a negative 1, and that would change this one here, the 3 minus x, into x minus 3. Because a negative 1 times a 3 becomes a minus 3. Negative 1 times negative x becomes a positive x. So if I multiply this one, or technically divide in this case, by the negative 1, it reverses the order. So what I'm doing is I'm going to take the 3 minus x and factor out a negative 1. So in this case, I'm going in reverse. By factoring, I'm dividing out a negative 1. So that becomes x minus 3. Now my x minus 3's cancel. I still have the 3 plus x and the x minus 1. And then the negative 1 out in front just makes the whole expression negative. So we have a negative 3 plus x over x minus 1. In E, 15 minus 3x over 12x minus 60. Both top and bottom, we can factor out 3's. So I'm going to factor a 3 out from the top, and I'm left with 5 minus x. Factor a 3 out from the bottom, and I'm left with 4x minus 20. So those 3's can cancel, and then it becomes 5 minus x over 4x minus 20. So that bottom can factor to 4 times x minus 5. So now, just like the last problem, the 5 minus x and the x minus 5 can match up if I factor out a negative 1 from the x minus 5 to reverse the order. So my 4 on the outside becomes a negative 4, and that means the inside becomes 5 minus x. Now the top and bottom cancel, and we have a negative 1/4. And the last problem that we're going to look at is F here, x squared minus 6x plus 8 over 4 minus x. So on top, x squared minus 6x plus 8 factors to x minus 4, x minus 2. On bottom, we have 4 minus x. So we want the x minus 4 and the 4 minus x to match up. So I'm going to take my x minus 4 and factor out a negative 1. That turns it into negative on the outside times 4 minus x. So that allows the 4 minus x's on top and bottom to cancel. So I'm left with negative 1 times x minus 2 over 1. So then when I take the negative 1 times x, that's a negative x. And then negative 1 times the minus 2 is a positive 2. So that simplifies to 2 minus x. Now, the rest of the notes that you see here, the evaluate the expression is just plugging in a number for the variable, which we've done many times before, and I'm not going to worry about practicing that right now. It's just now applying it to fractions or rationals. And then the idea of probability here, we're actually going to just skip over and not worry about. But if you want to look at the probability example here with area, feel free. But the key for you is to know this part up here, these 3 main ideas, and the examples below.